Hey guys, this is Mr. McKee again with Net 125. Today I'll be going over Packet Tracer 3.5.5, which is investigate the TCP/IP and OSI models in action. Alright, so this is, let's look down here. This is only questions. You got 18 questions to answer. Alright, so let's get started. Basically, pretty easy topology, web server connected to a web client with a crossover cable. All right, and we're just going to be watching packets going across the network. Okay. All right, so we're going to examine the HTTP web traffic and display elements of the TCP/IP protocol suite. All right, this simulation activity is intended to provide a foundation for understanding the TCP/IP protocol suite in relationship to the OSI model. Simulation mode allows you to view the data contents being sent across the network at each layer. As data moves through the network, it is broken down into smaller pieces and identified so that the pieces can be put back together when they arrive at the destination. Each piece is assigned a specific name, Protocol Data Unit, or PDU, and assigned a specific layer of the TCP/IP and OSI models. Packet Tracer simulation mode enables you to view each of the layers and the associated PDUs. The following steps lead the user through the process of requesting a web page from a web server by using the web browser application available on a client PC. Even though much of the information displayed will be discussed in more detail later, this is an opportunity to explore the functionality of Packet Tracer and be able to visualize the encapsulation process. All right. So first thing, instructions, part 1, examine HTTP web traffic. In part 1 of this activity, you will use Packet Tracer simulation mode to generate web traffic and examine HTTP. Alright, so first thing we're going to do, switch from real-time to simulation mode. In the lower right-hand corner of Packet Tracer interface are buttons that toggle between real-time and simulation mode. So it's from real-time right now with a white background. If I click on simulation, that takes me to, brings up the simulation terminal. All right. Packet Tracer always starts in real-time mode, in which network protocols operate with realistic timings. However, a powerful feature of Packet Tracer allows the user to stop time by switching to simulation mode. In simulation mode, packets are displayed as animated envelopes. Time is event-driven, and the user can step through the networking events. Click the simulation mode icon to switch from real-time to simulation mode. I've already done that. Select HTTP from the event list filters. Okay. So edit filters. That brings that up. Let's see. Did I click the wrong thing? All right, edit. Oh, sorry, not that. Let's do this. I see HTTP is already. Let's see. All right. Let me back up in this thing. Edit, undo, edit, undo. Control Z, Control Z. Show all, none. All right. Edit filters. All right, let's do that. It was already set to HTTP, but I wanted to go to it just to see it. All right. Events filters, visible events for HTTP. All right, HTTP already be the only visible event. If necessary, click the Edit Filters button at the bottom of the simulation panel to display the available visible events. Toggle the Show All None checkbox and notice how the checkboxes switch from unchecked to checked or checked to unchecked depending on the current state. All right, so that. All right, like I did under miscellaneous tab, HTTP. All right. Click the Show All None checkbox, which I just clicked, until all the boxes are cleared, and then select HTTP from the miscellaneous tab of the Edit Filters window. click the X in the upper right-hand corner of the window to close the Edit Filters window. All right. The visible event should now only display HTTP. All right, right there. All right. So generate web traffic. Currently, the simulation panel is empty. There are 5 columns listed across the top of the event list within the simulation panel. And you can almost see them, but I'm going to make this a little bit bigger. All right, now you see them all. All right. As traffic is generated and stepped through, events appear in the list. Note the web server and web client are displayed in the left pane. The panels can be adjusted in size by hovering next to the scroll bar and dragging left or right with the double-headed arrow appears. Click Web Client in the far left pane. All right. Click the desktop. One thing I can see though, it's weird why it's like that. You go to real time. Somehow I deleted my cable. All right. If yours look like mine with no cable in between, you're definitely not going to generate any web traffic. I'm not an expert, but yes, I think that's probably not going to work. All right, let's see. All right, click Web Client. Now that looks better. Click the Desktop tab. Click the web browser, which web browser is over here. Looks like a little, I don't know. It looks like a world with a line around it. All right. And then click the Desktop tab. Web browser icon, URL field, www.osi.local. And make sure you click Go. If you click Enter, it doesn't work all the time. It might take a little bit of time. All right. Because time and simulation mode is event-driven, you must use the Capture or Forward button to display the network events. And I clicked it twice. Maybe I shouldn't have clicked Go twice. The Capture Forward button is located on the left-hand side of the blue band that is below the topology window. All right. Of the 3 buttons here, it is the one on the right. So right there. Alright, so it wants us to look at this. Alright, so I clicked it once, a protocol data unit showed up. Once, twice, 3 times, 4 times. Alright, on the 4th time, it actually loaded the web server. We received a file from the web server and it displayed on the client browser. Alright, so explore the content of the HTTP packet. Click on the first colored square box under the event list type. Alright. Let me scroll this up a little bit. So your first answer, look at the web client web browser page. Did anything change? Should have already answered that. Alright, click the first colored square box. Event type column. It would be necessary to expand the simulation panel or use the scroll bar directly below the event list. Now, I did that, but this is the very first one up here. Alright. That's the very first PDU that went across the network. Alright. Let's see. There are only 2 tabs, the OSI model and the outbound PDU details, because this is part of the transmission. As more events are examined, there would be 3 tabs displayed, adding a tab for inbound PDU details. When an event is the last event in the stream of traffic. The OSI model and inbound PDU tabs are displayed. All right, that'll make more sense when we look at subsequent protocol data units. All right, ensure that the OSI tab is selected. It's right there with a little blue line underneath it. The other one looks different. All right, now you'll answer all these questions under the out letters column. Out letters on the right. What information is listed in the numbered steps directly below the in layers and out letters boxes for letter 7? Or I'm sorry, yep. Click letter 7. All right, so that's letter 7. All right, see how it displays something there. All right, what is the destination port value for letter 4? DST is destination, SRC is source port. What is the destination IP for layer 3? Layer 3, notice destination IP is right there. What information is displayed at layer 2? Right there. Click the outbound PDU details tab up here. All right, and this actually shows you what's inside the packet or the PDU. All right, information listed under the PDU formats is reflective of the layers within the TCP/IP model. Note the information listed under the Ethernet 2 section of the outbound PDU details tab provides even more detailed information than listed under the layer 2 of the OSI model tab. The outbound PDU details provides more descriptive and detailed information. The values under destination MAC and source MAC within the Ethernet 2 section of the PDU details appear on the OSI model under layer 2 but are not identified as such. And there's some questions. All right, notice all this stuff. Ethernet 2. You can look down through here. Source port, destination port. Source IP, destination IP. Source address, MAC address right there. Destination, source, things like that. What is the common information listed under the IP section of the PDU details as compared to the information listed under the OSI model tab? You guys could look at that, but just all the stuff I just looked at. All right, with which layer is it associated? All right, next question is what is the common information listed under the TCP? That was the IP section. All right, so all this. There's IP section. Here's TCP section. All right, and you label which layer it is. All right, what is the host listed under the HTTP section? And notice how you kind of like scroll down to see the host. You should recognize that host. All right, this is a lot of stuff that you just need to go through in the packet tracer. All right, so the answer to that. All right, which layer for under the HTTP section of the PDU details, what layer would this information be associated with under the OSI model tab? I'll let you answer that. All right, click the next, I'm going to close it down. Click the next colored square box under the events type, which is right there. Only layer 1 is active. Notice right there. The device is moving the frame from the buffer and placing it on the network. All right, advance to the next. All right, advance to the next HTTP type box within the event list and click the colored square box. All right. Right there. This window contains both in layers and out layers. Notice the direction of the arrow directly under the in layers column. It's pointing upward. Direction of the arrow under the in layers. It's pointing upward, indicating the direction the data is traveling. So the data is going like this and going over there and back down. Right, that's kind of hard to see because those arrows don't really stand out. All right. Scroll through these layers, making note of the items previously viewed. At the top of the column, the arrow points to the right, just right there. So you can go through all these, look at all the information. All right, and back down. Compare the information displayed in the in layers column with that of the out layers column. What are the major differences? So if you look here, if you notice, like the source and destination are reversed, ports reversed, even addressings reversed. All right. Starts at the physical layer, which is the port fast Ethernet 0, goes up through here, goes over, and goes back down out fast Ethernet port. All right, click the inbound and outbound PDU details tab. All right. Read the PDU details. I'll let you guys do that. So basically here too, these will be reversed. Some of these numbers will count up depending on what they are. Click the last. Did I miss anything? The major differences. Click the inbound and outbound protocol detail tab. Review the PDU details. Click the last colored square box under the info. Under the info. Info column. Right there. All right, how many tabs are displayed within this event? All right, you can see it there. I want you guys to look through this yourself. I mean, me going through it is great, but yep. All right, so in part 2 of this activity, you will use the packet tracer simulation mode to view and examine some of the other protocols comprising the TCP/IP suite. Display the elements of the TCP/IP protocol. View additional events. Click any open PDU information windows. Close any open PDU windows. Did that. In the events list filters, visible event section, click show all none. Right, so everything's gone. All right, I assume it's click it twice. All right, these extra entries play various roles in the TCP/IP suite. So notice you have like a DNS, so it's doing name to IP address translation, and ARP is IP address to MAC address translation, and TCP/IP or TCP three-way handshakes, things like that in your HTTP. All right. Let's see. The additional TCP events are responsible for connecting, agreeing on communication parameters, and disconnecting the communication session between the devices. These protocols have been mentioned previously and will be further discussed as the course progresses. Currently, there are over 30 possible protocols available for capture within Packet Tracer. All right, click the first DNS in the column. All right, there's right there. Explore the OSI model. All right there. And note the encapsulation process. All right, as you look at the OSI model tab with layer 7 highlighted, the description of what is occurring is listed directly below the in layers and out layers. So the DNS client sends a DNS query to the server. That's what we did first. All right. This is very useful information to help understand what is occurring during the communication process. Click the Outbound PDU Details tab. All right. What information is listed in the name field? All right. So the name is right there, www.osi.local. All right. Click the last DNS info colored square box in the event list. All right, so that's down right there. At which device was the PDU captured? All right, you should know it, but right here, it's at the web client. What is the value listed next to address? Let's see. Let's see, in the DNS answer field, all right, it's saying right there, that's your answer. It's trying to find out who is osi.local. All right, it's right there. 192.168.1.254. All right, find the first HTTP event in the list. And let's see, what is that next to address? Oh, we answered that. All right, find the first HTTP event in the list and click the colored square box of the TCP event immediately following this event. Okay, find the first HTTP. All right, that one. And hang on. And click the square box of the TCP event immediately following this event. So it'd be immediately following it would be that TCP event. Highlight layer 4. In the numbered list directly below the in layers and out layers, what is the information displayed under items 4 and 5? It looks like the TCP connection was successful and the device sets the connection state to established. All right. TCP manages the connecting and disconnecting of the communications channels or channel along with other responsibilities. This particular event shows the communication channel has been established. Click the last TCP event. All right, the very last TCP event. It's right there. Highlight layer 4. Examine the steps listed directly below in layers and out layers, which is right here. What is the purpose of this event based on the information provided in the last item in the list? Right? The device sets the connection state to closed. so it closes the connection between the two hosts. All right. Challenge question. This simulation provides an example of a web session between the client and a server on a local area network. The client makes requests to specific services running on the server. The server must be set up to listen on specific ports for the client request. Look at layer 4 in the OSI model for port information. Based on the information that is inspected during the packet tracer capture, what port number is the web server listening on for the web request? Some of you guys will probably be able to answer that, no problem. What port is the web server listening for a DNS request? All right. So based on the information that is inspected during the packet tracer capture, what port number is the web server listening on? All right. And what port is the web server listening on for a DNS request? All right. If you can answer those, I mean, if you guys are doing all these packet tracers, you probably don't need to do the challenge questions, but I can give you a little bit extra credit. You might have to email me and remind me. But yeah, usually it's the people that don't do any of the assignments that have the hardest time or do them late. So if you do them on time, you should be good. All right, but that's it. That's some of this stuff gets a little tricky clicking on different stuff in the simulation screen, but it kind of like shows you how stuff flows. Now this is super simple. When we have a lot more topology is a lot busier, it has routers, switches, you can see how the PDUs flow through all those different devices, and it's pretty neat. All right, but that is it. Should be the last packet tracer for this week, but I will make some more for next week. Thanks for watching.